So we started talking about backyard composting, which also applies to when you are making small piles of compost in your gardens and others. Usually people use different, is it okay now? Usually people use different types of composting systems or bins or whatever, depending on what you are doing. And you have a whole host of different types. This is the small plastic container that most people usually use, the earth machine. It's one of the most common ones around the world. It's easy to use. If you fill it up at once, what I normally do if I want to use this is to at least fill it up to here at once, get enough material. If you do it the first time like that, it actually heats up well, and it can even get to the 60 degrees in the core. But if you just go, you put a handful of your waste and a peel of banana, and you continue doing that, it will never get to that temperature. So if I start like that with large quantity of manure, wood chips, and everything to start with, and then I can add other things to it and mix it into it, it will maintain the temperature. Just like that, either that or this one is more or less like a roll-out bin. It's got wheels, but it also got holes at the bottom. But also it has a door here. And the door is the one where you can, after it's composted, you can open it and take things out. The earth machine that I showed you earlier on is one bad thing about it is how will you turn it? The easiest way to turn it is not to put shovel in there. Especially those that are conical like this, the easiest way to turn them, because they are easy to pull it out. Just pull it out, put it on the side, and shovel it back into it. Even if it is full, it makes it work. This one is more or less, it's a four-sided one. You will see that it looks like pallets. Like they use pallets, okay? But they use plastic to make it, just like the prefabricated plastic. Which takes us to the one that is almost like that, where you can use pallets yourself. If you have 3 or 4 pallets, you can set them up just for the beans, and then you can fill it up with material for composting. This one is actually, what I'm saying is that you can be creative. You don't have to go and buy those plastic containers if you are going to do your own. This one is an example of the one that is, you know the reel that they use for cable?
Yeah, the wire spool.
Yeah, the wire spool. It's the one that has been converted into a composting bin, and is put on a stand so that you don't need to shovel. They put an opening here, and then whether it's filled or anything, instead of shoveling, you just go there and you roll it. You see, they put in the axis, they put like a metal to hold it, and then they put it on a stand. You will see that this actually works very well and fast, and it reduces shoveling. You will see what it will take for you to shovel today when you are making those ones. This is another one similar to that, but it is prefabricated. You can look at it better here, but also here. It's just also on a stand, but prefabricated metal with an opening. They make it after the one that I showed you. This is another prefabricated one. All these ones, you can roll them. They have openings, but still the problem is how much can you put in them? The problem with many of these backyard composters is the fact that when you look at how much it costs you to how much is compost to get out of it, you pay a lot of money for it. Some people will buy one, pay $40 or $50 for it, use it for one season, and they get like $10 or $20 worth of compost out of it. You really have to use it well, and you have to use it often. This is another type, but instead of rolling it, it's a tumbler, the one you tumble. Okay? There are different types of the tumbling ones. This is another type. And then this one is just, you can either buy this, or you can make your own using chicken wire or other types of wire. When you are doing those, let it be at least 3 separate bins. What happens is, when you start with one, when that one is full, especially if you have large farm like this, or a large yard where you cut a lot of grass, so that when one is filled up, you can then know that you have to start filling the next one, and then you can turn that into the one on the right. It's a 3-beam system. This is almost like that, but they build it like into a big, under like a structure like this. And each of the bin is so big that you can drive a front-end loader into it. And they are made of big bricks. And those bricks are like Lego bricks. So they use it to just lift it up. Two characteristics of this is the fact that under here, under the concrete, they put in the pipes with aeration holes. Okay? So that if you are using this for manure, even mortalities on the farm and others, you'll be able to put in a lot of oxygen when needed. So, under those pipes, the pipes are in the concrete. Those pipes are connected to pumps at the back of this structure. There are a series of pipes of blowers, and the blowers aerate it. There are two ways of controlling the blowers. One is the temperature feedback. When you put a feedback in there, you just set it, if the temperature is below, let's say 120, it will come on for 5 minutes. So immediately the temperature on the pipe is getting below 120, turns it off. And then it blows for 5 minutes, and then watches the temperature go up. If you come back down again, it does the same thing, the blower comes in. Or some people actually, based on experience, you say, well, every 2 hours, I want the blowers to come on 5 minutes every 2 hours. So that whether you are there or not, every 2 hours, it blows there through. Every 2 hours, it blows there through. So you can set it like that. So you put the timer on. Remember, your backyard composting, you cannot put milk products, fat, or meats. The only reason is because of odor problem and because of pathogens. And they can attract vermin, everything from rats to other type of things. Large bones, because it won't compost. Pet droppings, because the pathogens. Pet droppings, because the pathogens there will not die enough quickly. That's the only reason. And then, plants that have weeds on them, that have seeds on them, you can use regular, when you cut your green grass, but once the plants are seeding out, and the seeds are maturing, you don't put those in your backyard compost. If not, the compost you produce will have a lot of seeds in them. So, I've shown you the wire mesh system, the portable wood and wire composting bins, the stationary 3-bin system, we look at that, and the barrels and the drums, that the ones that we have looked at. So what I want to do, quickly look at now, will be to talk about the systems for centralized composting. What I mean by centralized composting is the situations where you are taking a lot of materials coming from different places. Because there's nowhere where you are going to be producing, let's say, 10,000 tons of compost. You are receiving the waste from somewhere else. And then they bring it to a centralized location to compost. Or even if it's 500 tons of material, you bring in the manure from somewhere else, you bring in some materials from the farm, you bring in materials from the municipality. The reason why they use this in many of the situations is it aids in the reduction of waste that goes to landfill, but also you produce a product. It promotes environmentally good practices for waste management, and it treats household and yard waste and divert this waste from landfills. So, I will talk about 5 different systems, general systems. The 5, I will mention them. One is static pile, when you pile material. Okay. The second system are those where rather than you pile them, but in a windrow. A windrow is like a big ridge, long ones of those. So, like this area here can actually take about at least 20,000 tons of material. But each row may be 7 feet high, 14, 20, 15 feet wide, and it goes. Okay? It may go 200 feet or 200 yards, depending on how much space you have in there. Those are what we call windows. Then I'll talk about static piles. It may be in Windrow system or static piles that is aerated. So that, because the first one is the one that is not aerated. And then we are going to talk quickly about the vessel systems. Systems that are in a container, specific container, large systems with containers. The passive static pile. When you say something is passive, it's not active, it's not moving around, or nothing moves through it, it just sits there. Okay? The most important thing in a passive aerated system is the fact that you don't turn. It is not turned. Because it's not turned, it requires that you mix the material properly initially, which means you must have material that you allow air to go through it, a material so that you don't need to turn. So that's what we call a static pile. The main advantage of a static pile, passive static pile, is that when you calculate how much it costs you, it's inexpensive. You just need the area, you mix the material, pile it, leave it. But what you realize, even if it works well, is that the consistency. You'll find pockets in it that might have been anaerobic. Yeah, you get, most of it will be dark brown, and then you see some light brown area. Most of it will break down easily. Then you see some clumps that don't break down easily inside them. So inconsistency is one of the biggest problems. Therefore, the product you produce tend to be low quality, and in many cases, they may actually have more phytotoxicity. You have to leave it for a longer time for it to reduce phytotoxicity. And the other thing that is also very bad about static piles is because you didn't turn it in. Often you have problems with weed seeds and pathogens, especially on the outside of it, even if the temperature reaches 50 degrees Celsius or 140 degrees Fahrenheit inside. So many times, people that are using, if you want to use static piles to produce compost, once the compost is ready, they actually remove a little bit of it outside and remix it with other compost to be sure that if there's any pathogens or weed seeds there, they are destroyed. So, I've mentioned the Windrow composting. You don't see anything here, don't worry. But in Windrow composting, you set the windrows, which will depend on two things: the amount of land you have and the size of the equipment you use for turning. If your equipment that you use for turning is a big windrow, in one of those monstrous windrow turners that is as wide as this room, then your pipe can be as big as this room and as high as that equipment will go. If it's in a very warm environment like this, we don't really want the pipes to be too high or to be too big, because it's going to be to overheat. Okay? So, and then it depends on the type of material that you have. So, like this one, you can look at it here, you actually see better here. There are piles of rows of material that you have in here. If it is a windrow, then there is something for you use some equipment to turn it. Okay? This is one type of equipment. See this big stuff. And you'll actually see it better here. This is the windrow turner. Okay? There are different types of windrow turners. Many of these turners, they do 2 or 3 things together. 3 things. Minimum of 2, but 3 guaranteed. 3 can be as many as 3. One is that they turn the windrow as they drive them through. It aerates it. The second thing, even though it mixes it, it forms it back. So it goes through it. It's not like it just scatters it. It forms it back. But what you realize is that for many of them, because the drum that moves, that turns, it actually has on it like knives that are shaped at different angles, depending on how you want it to form the windrow. So when those pieces of metal, when they are going through your material at about between 3,000 rounds per minute and 5,000 rounds per minute, they actually cut some of the larger materials into small pieces. So every time you turn, you realize your material gets smaller and smaller. The quality of the compost gets better and better. Okay? With the windrow, with this type of windrow turner. Somebody was mentioning it to us that there's a small one of it or something like that somewhere in, I think it was in Grand Bahama.
What's that or what?
A windrow turner. Somebody mentioned
Yeah,
that,
yeah, yeah.
that they have a windrow turner for one project in there. I haven't seen it. I haven't seen a windrow turner any other place in the Caribbean.
Yeah, they
But-
said, yeah, but after the Orient, I think they have some equipment there.
They said they have a small windrow turner. Like this one, if later you come to look at it, you don't see it here. In the par, you actually, behind with this windrow turner, you actually see steam coming off the par. There's steam coming off that par from the windrow turner, or from the equipment. With the windrow system, when you look at it, it's actually cheap. When you look at the turner, for example, how much it costs you to produce a cubic meter. Okay? That equipment is true maybe $100,000. But that equipment can turn 20,000 tons of material in less than 3 or 4 hours. So if you are producing 20,000 tons every 3 months, that's about 60,000 tons every 9 months, or almost 80,000 tons of materials a year. That equipment, we handle it with 1 or 2 people alone, managing that. That's a lot of material. And in some situations, especially, we were talking about the situation in Abaco and the Grand Bahama after the Hurricane Dorian, with the numbers of trees that were down and things like that. If you can put everything together in 3 or 4 locations, grind them, add some other things to them, you can actually produce at least 1 million tons of compost that farmers and everything on those islands can use to rejuvenate the ground, the soil. So it tends to be inexpensive. It's easy to manage. When I say inexpensive, per cubic meter you produce, it may actually cost you. The one that I showed you yesterday, when I was showing the economics, was based on a windrow turner. It turns out that it was costing less than $3 or $5 to produce a ton of compost. Okay? The major disadvantage is always the cost. People say, well, the equipment costs this amount. But if you have the material that you need to compost, you can, if you hire people to shovel it every 3 or 5 days, then you have, you even have more than 5,000 people doing the shoveling. Because each one of them will shovel about 4 tons of materials every day. Okay? So, it will cost you more. You spend the amount you use to buy the equipment in less than 2 or 3 weeks to pay those people that are doing the shoveling for you. Okay? There are different types of those equipment. It will depend on the type of material that you are dealing with. For example, if you have wood chips, you have plant materials that you want to compost, the type that I told you that we have, like the paddles that can cut material, is good. If your material has very high quantities of soil or other things in it, those will not work well. It is those that have like ogre system that pushes the material sideways, wind and turn it in the process. That tends to work better, like some of these ones like that. As I've mentioned, when you turn the windrow, it mixes, it adds oxygen to it. The other thing it does is, in situations where your piles are getting too hot, it cools it down because it aerates it, it cools it down. It's not in all cases that you have to buy this type of windrow turner. The best equipment for a small scale windrow system is to use a front end loader. Okay? So for example, if you have only, let's say 1,000 tons or 2,000 tons of material, which is a lot here, I would not recommend that you buy that type of equipment. If you have like 2,000 tons, it's good enough for you to have a front end loader. The best way to do it, when you are setting up your windrows, take into consideration the size of your equipment, so that the length between each windrow will be at least the length of your equipment. Because to turn with your front end loader, the easiest way is not to scoop and mix it. The easiest way is to flip it. You put the window, you put it on, flip. move, flip. You are keep flipping inside, out, or outside, in, outside, in. And the way you arrange it is really important. You arrange the oldest material first, then the next one will be the next oldest, newer, okay? So you go from the oldest to the newer. There are two advantages of that. If I have the whole of this place, I will start there, put my material. Once I finish the row, and I want to remix it, I will flip that in here. And where I started before is where I'm going to start the next window. What that means is that my oldest window that we always ready will be closer to here. And the newest window will always be on that side. Does that make sense? There are two advantages to that. When you want to start to turn every time, you start with the old ones first and turn it to the newer one. You start with the old one, the one that's here, you move it. By moving it over, you created a place to move the next one. Does that make sense? But when you look at it, your old compost pile, you want to maintain the lack of pathogen in there. So every time you want to turn, is the one you turn first with the clean equipment. You turn the old ones first because that's going to be the one without pathogen. Followed by the next one, followed by the next one that is still in the active phase, followed by the raw one. So then you clean that equipment for that day. Does that make sense? If you don't do it that way and you start with the newer one, every time you are going, you are recontaminating your old pile.
Okay. So you're flipping it from the bottom?
Yeah, what I'm saying is that the first windrow, let's say all the material that comes in the month of January, I make it into one window. I start it here. I start the window. Then, at the beginning of February, I decide to turn this window, move it over.
So you say turn, you mean flip it?
Yeah, I flip it. I flip the window this way.
Okay.
Then I will form the new window here for February. When it's March, I move this one over. I move this one to this point.
Okay.
I still use the same spot where I normally start for March. By April, the one for January is here, the one for February is here, the one for March is here. In May, this one now, I move it over to here, come that way. If by June everything is ready, I will always harvest the one that is ready here. Does that make sense? But it's good for my equipment. If not, what you will have to do is every time you turn a windrow, you have to clean up your equipment, disinfect it, so that you don't transfer pathogens from one to the other. But in this case, if you start cleaning, if you always start turning with a front end loader especially, from the last one is always the one with the least amount of pathogens. Does that make sense? It's expected to be the least amount of pathogens. So you clean that one, the next one will be the fresh one that are just coming.
So you use water when you clean it out in the tin?
You use what? Water?
Yeah, clean it out.
You use water many times to clean your equipment. You use water to put on the windrows. The advantage of windrow system is that if it is too wet, if it is too dry, for example, you can easily spray the pile with water before you turn. And if it is too dry, you can just sprinkle some more wood chips on the windrow and turn it in.
No, I think the question is like, do you sanitize the equipment before you?
Yeah, you sanitize the equipment after each day.
Okay.
But normally, if you don't follow the instruction that I gave, you have to sanitize the equipment after each row.
Yeah, after every time you clean over the pile, you clean the equipment.
You clean your equipment, exactly.
Okay.
But if you have 6 rows, 6 parts, and you follow that rule, you only clean it once.
Okay.
If you start with the old part, you only clean it part once. If you start from the clean area, every time you do one row, you have to clean your equipment. Does that make sense? Okay. I'm just saying that those are some of the methods of reducing labor.
So if you are in a smaller pile, like a backyard pile, you use the same guideline.
If let's say you have 3 parts, in your backyard,
Yeah,
I will start with turning the old pile first.
right.
When I finish that, I turn the next one, I thought the next one, I won't claim start with the new one, with the newer one, because the newer one will definitely have pathogens and other stuff in it. Okay? As I've mentioned, the front end loader is one of the best equipment. There are different types of this equipment, and there are some that are actually small, a window turner, that some people, different companies are producing, and some farmers, like in Canada, the most innovative set of people are farmers. Most farmers have in their own backyard or in their own farm, they can actually put together, if you say this is an equipment, they will actually build their own. They use some that they use for busting or breaking hay. Some people use it to turn their windows. For example, in some places, some farmers actually use the hay spreader. The hay spreader, the manure spreader, let me quick manure spreader, to form their windows. Somebody will be driving the manure spreader, and somebody will be dumping materials in there. As manure spreader spreads, pushes it on, it forms a perfect windrow. And then before now, they should start to turn it. Okay, now, let me quickly move on to just talk quickly about two other things before I'm checking our time. We have only 20 more minutes. We've talked about how often, when the temperature drops, when you are smelling, when there's odor, it means there's no oxygen. And in some times, if I were you, if it is a big facility, even if it's not stinky, especially during the fly season and other things like that, you have to turn more often, like once every week. Make sure you turn it once every week. It's good. And as I've mentioned, at least 5 times altogether during the active composting period. The next one, you remember we've talked about static piles that are passive, that are just there, you pile them. The next type of static pile are the ones that are aerated static pile. People will say, you talk about aerated and static together. Can those two words go together? Yes. Because if you can put your static pile and you make a way of blowing air through it, then that pile you don't need to physically turn it to aerate it. Aerated static pile are divided into two. If it's an aerated static pile, you have something in it to make the air go inside intentionally. The first one are the ones that we say are passively aerated. You don't put any fan in it. But you are using the technique because we know that the window takes air from the bottom, fresh air from the bottom up. So if I'm putting a big pile down here, and I realize it's going anaerobic, I may decide, oh, now that I know that it sucks air from the bottom up, why can't I put some pipes at the base? And I put holes in those pipes. When the pile needs oxygen, it sucks in oxygen from the bottom. You understand what I'm saying? Mm-hmm. Then that is a passively aerated static pile. I'm not blowing air into it, but I've created tunnels for the air to flow through. Does that make sense? So sometimes you see some people building that type of system whereby if they are going to be doing composting in this room, in the other this shed, they actually create the places that they want to put windrows. If it's going to be 3 rows of windrows there, when they are pouring this concrete, they've already put into the ground pipes inside the concrete, like PVC pipes or any other thing, that they put holes in. So now, once you pile the compost on top of these holes, when they need oxygen, you can actually, if you put something to measure airflow, you actually feel air moving on its own because the compost is sucking out air. It's a passively aerated system. Does that make sense? If it is actively aerated, what that means is that at the end of each of those pipes, you can actually put a fan in there, and the fan blows air into it. Does that make sense? So, if we can put a fan to blow air into it, it's an actively aerated static pipe. Like the example that I gave the other time, whereby you pile it in the system, but the system automatically turns on and blows air into it. It's going to be actively aerated static pipe. The other fact is, when you are blowing air into it, to put air in a pile, you can either blow air into it, or in some situation, you suck air out of it. If it's a big pile, if you blow air into it, the way air moves is it moves in, it goes up, it comes out. But there are some situations when we realize that we are working with materials that may be producing a lot of odor. And I don't want to stink up the whole neighborhood. Instead of blowing air into it, I may decide to suck air out of it. It will be taking fresh air in from the sides rather than from the bottom. Does that make sense? So you put pipes under it, and that pipes you can suck the air out just like using straw. Suck the air out of it, and the air goes into what we call a biofilter. That biofilter therefore becomes a way of treating the stinky air, and nobody will smell anything in your neighborhood. So people use activated static power, positively aerated static power to blow air into it, negatively aerated static power, active static power, to suck air out of it, to remove odor and other things like that. And I will show you a couple of examples. So if it is active, it uses fan, but it can be either pushed through or suck air out of it. This is not very clear. What this is showing is this. It's a situation whereby, assuming that we have in this area, you are going to put a static part here. And you have underneath it a pipe. It may be PVC pipes and everything with holes. And you pile everything. The pipe goes all the way from here to the end there. You know, I can put at the end of that point, even if I have 2 pipes or 3 pipes, I can put a blower pump that blows air into it, to that pipe. Okay? But when it comes to the time when I'm doing a particular project, and I realize that the material is stinky, a lot of pig manure in there, other things, I can convert this quickly with no or little or no cost to a negatively aerated static part. All I need to do is at the end, when I'm blowing air into it, I turn my fan the other way. Do you understand me? You turn your fan. Instead of blowing air out into the compost pile, it sucks air out of it. And then, from that blower, I will take the air into a pile, either into the soil, or you put a mound of compost that has been finished, or a mound of wood chips with low nitrogen. You realize that it is going to take out all the nutrients and all the odor in your compost pile. Yes? Mulch and wood chips are basically the same. It is the purpose you are using, whether wood chips or bark or any of those for. If you are using it as a cover to suppress growth, to keep moisture and anything, then you say it becomes a mulch. It is because of the function of what you are using it. Yes?
You see moss?
Sea moss? You can use any of the sea weeds or anything, but they will break down also. All those will break down, and therefore they may not necessarily be very good for porosity.
Does the dye in the mulch affect the quality of the compost?
The mulch itself?
No, the dye.
Yeah, the dye, it can affect. Now, the mulch, if you are talking about the treated mulch, because you see, the one you are talking about now is that you see, many of the mulch that they sell to people, they put a dye just for aesthetics.
Right, but it does not dye for.
If it is that type of mulch, then I will not really suggest it, because that will color your compost or affect it. I don't know, depending on the type of dye. If it is a dye that is water soluble and doesn't affect organisms, no problem. If it is one that can affect plants, then I will not use it.
Yeah.
That's the reason why we don't recommend that you use treated wood, for example. Okay? Because many wood, they are chemically treated, and then some of the chemicals, especially chlorinated organic compounds that they use on them, will be passed on to your compost.
Got it.
Okay? So, I have talked about passively aerated piles. I've talked about actively aerated piles and the advantages and disadvantages and the way you can program the system. Now, before I talk about the universal system, I just want to then quickly talk about what we are going to do today and why we want to use this. What we are just trying to do today is to use a modified passively aerated system. What I'm saying, you have to find a way of delivering oxygen here into your pipe. And in this case, we want to use the pallet as the base so that air can flow under it. Does that make sense?
Yes.
If you can pile the compost on the pallet, when it needs air, it takes air from bottom, it goes through it easily. It's like putting a pipe or pipes at the bottom of it. Okay? Because if we make this compost pile, even though they are not too big, and I have the strongest person every day come here and shovel it and turn it, it's a lot of work. So, but to pile it on there, we don't want everything to go through. We are going to put the landscape fabric on top of it. We pile it on, and you realize that for this type of compost pile, it works. If you are going to do it in your backyard, if you just you pile your compost on the ground, it goes anaerobic quickly. If you put it on an elevated surface like that, and air goes through it underneath it, it works very well. So we are going to use even through the fabric. That fabric itself, it allows air and everything to go through it. It may sometimes, depending on which side you put up, disallow water to go through it. Okay? If you have concerns about that, in some situations you can use any other type of material that allows air to go through it more. But I can tell you the air that will go through this will be almost good enough. Okay? So we are making a passively aerated static pipe. That's what we are going to make today. For the one we are making today, you are having possibly at least the two main groups of material. And which ones are the ones that they have here? Do you have manure? Any manure or green manure? Chicken manure. We are going to have chicken manure. Which one is the chicken manure that they have?
All the way to the end.
At the end there. Okay. And then this one and this one are the brown material, see? Which one is your brown material?
Raw material?
Brown materials, the leaves.
Right.
Okay?
Yes, and I see cardboard over there.
Yeah,
too.
cardboard.
That's okay. All those parts, they are all brown materials. You remember yesterday, I said brown material doesn't mean they really have to be brown, it's because they are good source of carbon. Then the green materials and the manure will form one another.
We could get some of those to use off of that.
No problem, no problem. So what we are going to do today is scientific and at the same time not scientific enough. We say we are going to have a pile of brown materials, pile of brown material with one unit of brown material, 1 unit of green material. And then another one unit of brown material, 2 units of green material. So the first one is 0 to 1, the next one is 1 to 1, the next one is 2 to 1. So as you go from the first one to the last one, the amount of nitrogen increases. Does that make sense? We expect you to get different temperatures in there. If scientifically I am to set up an hypothesis, my hypothesis will be as you increase the amount of nitrogen, the rate of composting will increase. Okay? Because
How often would you turn that?
what I want us to do is not to turn it. That's the reason why we make it passively aerated system. Static one. Does that make sense? If maybe later, if the temperature goes down, people can then turn it and look at it and everything, then we can follow up with a web-based class and things like that to see what is the quality, and then we look at the data. The data you collect on this normally should be on a daily basis. Okay? Should be on a daily basis where you collect the temperature, but at least once a week, if the person taking the temperature, if the person can at least feel it, go put his or her hand in it, feel it, whether there's enough moisture in it, if it stinks and any other thing, just take those type of notes. I will also recommend that whoever is taking the temperature on everything, you arrange it whichever way you want, going from left to right, 0, 1, 2. Yeah, she's winning. Every day, you take the temperature, just snap the three of them together. You don't have to snap them individually. If you snap them individually, you don't see the difference. Every day, snap them together. From day 1 to 2 to 3, each day you don't see much difference. If you take day 1 and compare with day 10 later, you see the difference. Because what you find out is, for example, your number 3 would have gone down more rapidly. It may be the biggest year you start, it will go down more rapidly in terms of shrinking and other things, other characteristics later. Okay? So we have 8 more minutes. I want to talk about the other type of systems for composting. Those are the ones that are called in-vessel systems. They tend to be more expensive. Can you imagine? Instead of just piling the things in this room, if we build it up, cover it, put here system, blowing here through it, taking air out and everything. Everything is contained in a system. Those are what we mean by in-vessel system. The compost is enclosed in a vessel. It's usually used only for, in many cases, they use it during the active phase because it tends to be more expensive. They don't just let the compost sit in it. They use it for the active phase, and after the active phase, they take the compost and pile it outside. Often, they use it in systems where the waste management process, where there's a lot of money for it. For example, municipal solid waste. If a municipality, I will show an example of one municipality of, like in Alberta, the capital of Alberta is Edmonton. Edmonton was producing close to, I would say, the population is close to 1 million people in Edmonton. So, they are producing a lot of garbage. They spent $120 million to put on a big composting facility. But you know what? In less than 5 to 10 years, they got their money back. Because they were spending before about $50 million every year just to manage the waste. Now all the materials go into the composting facility. They do the composting. After that, then they separate some of the material. There are equipments there that separate everything. Not that people are picking everything. And now they are producing millions of tons of compost every year that farmers can buy. They use it for reclamation. They use it on the side of the roads. They use it in the public parks and everything. Instead of buying all those, they use it for those. Now, the material are contained in a room, under a roof, and in a wall. And in most cases, there's a continuous way, or on a continuous basis, of putting air through it. In a lot of times, it's possible to even to control the temperature artificially, if you want to, whereby they can use a heater, they can put a heater system in there to achieve the 3 days heating requirement, or they can blow air through it to cool it down. Some of them work in batch systems, others work in continuous systems. A batch system is one where you bring the material in, turns it stays in there, but a continuous feed system will be an example. Let's say instead of, in this room I divide it into 2 big tunnels, okay? They put a wall here, a wall at the end, and a wall here, up to around here. And you can keep on feeding both sides on this side. You put in 5 tons today, 5 tons of that one tomorrow. If there's something that I put in each of those tunnels, every day it moves the raw material a meter forward. What that means is that every day I will be able to add more new material here. And when it's going in the tunnel or in the vessel, it's mixing it, it's turning it, it's adding air to it, even if there's need for moisture, spray moistures on it. And there are equipment that moves it. You will realize that if it's moving it a meter every day, at the end of 28 days, if the whole of this room is about 28 meters, the whole compost will be coming out at the end there. Do you understand what I'm saying? And therefore, every day at the end there, if you are putting 10 tons of material at this end, every day out there, you will be getting the product of the 10 tons of compost coming out. It may not be exactly 10 tons of compost, maybe it's going to be 6 or 7 tons of compost, or the product of 10 tons of compost of material you put in at the first time. That is basically the principle of all of them. There are different types of these type of continuous systems. The first one is that I've explained to you is the agitated bed, whereby they go in a tunnel and there's something that mixes it. And then from the bed of the material of the tunnel, it aerates it. Okay. That is not very clear. That's not clear. Another type of inversion system, besides the agitated bed, is the one that we call a rotatory drum. A rotatory drum is more or less like a big cylinder. Some of them will be 30 feet in diameter. And it may be like 200 feet long or 300 feet long. It's a big drum. But inside it, it's got some paddles. If you can put it at an incline, let's say 3% or 5% incline, and you are feeding it here, and that drum rotates, it will move the material inside it gradually. You understand what I mean? It moves the material inside it gradually as it rotates. In fact, sometimes it rotates, people cannot, you have to stay there to really know that it is rotating. It aerates it, and the material moves through. In many cases, the angle of inclination will therefore determine how quickly the material moves through. If it's only, if they want it to stay in there for 2 weeks, it will be like 1 or 2 degrees. If they want it to move in 3 days, it may be at 4 degrees incline. Does that make sense? This is an example of those. You can look it better here, but you see the drum. Long drum. It shows better in here. People can see it. The diameter of this drum in this case is about 30 feet diameter. So, and in this particular sample place, they have 5 of them lined up. 2 on one side, 3 on the other side. So all the waste of the city goes through here, coming from this side down to this side. It turns, yeah, it rotates. It just rotates. It rotates. There are some portable ones that the Bedminster system, as they call it, Bedminster composting system, which sometimes people can buy and they can try it out and to see that it works and things like that. This system is expensive. It works well, but it's very expensive. And the fact is, when your material comes out on the other end, it still has to go through the process of completing the composting process and curing. It only guarantees that the material satisfies the regulatory requirement of 3 days in an in-vessel. You will see the material is already turns really, really brown material, but it still stinks. So they will then pile it and let it go through the other phases of composting until it's ready to go. There they have other mixers and other things in there, in a big room. The room where it is like 5 football field, where all this material goes, and then they can finish the composting in it. This one, well, if you are look before you may see actually see it better than my name close. Is another type of in-vessel system, but this is the type that, yes?
I was wondering, how much days does it take for the compost to be fully mature?
Well, I said the other time, earlier on today, one, it will be affected by 3 or 4 things. One, the type of material you are composting. You remember I used the example of the situation where we are composting offals, we are composting bark, we are composting fatty material. The time it's going to take will depend on the material you are composting and which systems you are using. Okay? If it is just typical ground yard waste or yard material, and somebody is managing it right, okay? Usually it takes about 4 or 5 weeks for it to go through the active phase, and depending on the type of material, another 2 weeks to 4 weeks to cure. So when you add everything up, it's going to give you everything from 6 weeks to about 3 months, okay? But that is if everything works out well, but it doesn't always. And not everybody that manages those type of composting facilities or composting system manage it well. Either they don't turn it right, they don't add enough moisture to it, the pile is not big enough, and a lot of other factors. Yesterday, we talked about how do you test for it. You remember I showed that yesterday. So that you know when your compost is ready. I rather talk about how do I know than how long does it take. Because how long it takes will depend on the type of material that you are doing. This one if you see better here, it's just green like that. It's another inversion system whereby materials are fed in on this side. You climb on this wall here, maybe you see it better here. You go on the steps and press the button, it takes the compost material, the material you want to compost, dumps it in, and over a period of 28 days, it dumps it in every day. And over a period of 28 days, the material will move from here to the end here. If you look carefully here, you will see that at the end, the material actually goes through a screener. And it is screened, and your final compost comes out. 2 parts of compost here at the end. Screened compost. That compost can then be checked. If it is still phytotoxic, then you can take the compost away and store it away and let the phytotoxicity stop. Does that make sense? Okay. I see that it's already 12 o'clock, and I will stop here and let us just do what we said we want to do. As I've mentioned, this is how we are going to do it. All the brown materials, mix it together. The brown materials. Mix them together, whatever the size that we have. And then we divide them into 3. Okay? All the brown materials. We put everything together. If these are brown materials for that or that, we put all of everything together. Whatever we have as brown material. And then we divide it into 3. Separated on the ground. One of those 3, we put it on the first pile. Does that make sense? That's the one we don't have any nitrogen to. Then all the nitrogen material or green materials that we have, the manure, the green leaves and everything, we mix them together, whatever the quantity we have. Then we divide it into 3. We will add 1 part to the second part of the green or the brown material, and we mix them together. Does that make sense? I will suggest that while we're mixing them, we put enough water, and then we test it that the moisture is okay. Before then, we pile those ones for the second one. Then the remaining 2 parts of green material and 1 part of brown materials, we mix them together also. And then we water them while we are mixing, and we pile it on the third. So we now have 0 to 1, 1 to 1. It doesn't mean exactly the same weight. I'm just saying 1 time per part of green materials or manure or whatever to 1 part based on our own distribution, our own system of brown stuff. And then 2 where you have more green material than what we have in the second one. As I said, what you will notice over time is that the one that has more green material, which is the third one, the temperature will start off faster. This is an experiment to show you that green materials are required or necessary for the process of composting. And it will affect the rate at which it composts and how long the composting process. We'll collect the data, hopefully, during whenever we have the next process, whether it's a webinar or another class. We'll then review the data, and then we'll review the compost quality. Hopefully, the other thing that I would suggest, if there's any resources available at the end, we've now worked in 4 locations. If we can take all the three samples in each of the 4 locations, we'll get 12 samples. Let's take all those 12 samples, let's send them out for an analysis, if we have the resource, and look at the differences in the quality of compost that we produce. Because, yes, the first place we use chicken manure.
Yeah, we use chicken in
Nabaco, yeah. But the chicken manure seems to have undergone a lot of some changes. The chicken manure, the way they pile it.
Yeah, it wasn't fresh.
Yeah, it wasn't fresh. So we use fairly aged chicken manure with wood chips in Nabaco.
And coconut.
With some coconut husk and everything.
And then green material.
And some green material. In Grand Bahama, we use pig manure. So a lot of green material that we can harvest in the area, for some brown materials from the leaves and everything that we get there in the area. And then, yes, 2 days ago in Nassau, we used,
Sheep and goat.
which one?
Small rumen manure.
Yes, small media, sheep manure, plus some other brown stuff. The brown stuff we do use there were mainly some grass
Yeah.
that has been cut and has stayed there for a long time and turned brown. And we also use some green, a little bit of green leaves and everything we added to it to supplement the cow manure.
And a small amount of food waste.
Small amount of food waste without plastic. Today we are going to do the same. So if we can compare the value, the nutrient value, there's a basic analysis to do for composting. Then we can actually look at it and create like a table. This one works well, this is the temperature you get to, this one kills the pathogens and all this, so then we can compare it. So you have all the various groups in different countries can then share opinion on how things work. Any questions for me? Preguntas? Here we have the mechanical thermometer. The mechanical thermometer works by a bi-metal tube inside this tube that when it is being heated, it rotates because one side expands faster than the other. And you read it here. The problem is when you put this in your palm, you have to give it time to stabilize. 5 or 10 minutes until, because when you put it in, if I touch it now, to read my body temperature, it may take me 10 minutes. You see it just going up as gradually as possible, okay? But because of its slowness, because of the fact that different people at different times you go there and you could look at it from different angles, you are too much in a hurry or anything, you don't get accurate readings. People now, or we have available other type of thermometers. An example is a digital thermometer. Instead of the long stick here, you have what we call a thermocouple wire. It's still basically the same thing. There are 2 wires in there that are put together. And immediately, if I hold it, immediately I turn it on, it shows the temperature. Everybody will be able to see that it is 97.2. It gives you the number. Okay? Immediately. So what they do in many cases is we put this type of wire permanently in your pile. And anytime you just come, just plug it in, you read it, it takes you 5 seconds, you've read everything, you're gone. The only other advantage of this system is the fact that you can actually tell it to hold the readings inside. And then when you get to your office, you can just go through it and copy them. Because this is faster, it's often more accurate. For example, now, I just put my finger on it, and it's going rapidly up. It goes to 96.6, between 96.6 and 96.8, 97, which is the body temperature. That's what it is now. It's quick. Now, this works very well. We are going to leave one of these and one of this other one. Okay? We will test this after you have mixed it. This measures the water content. Okay? It just measures from 1 to 10. 1 to 3 is too dry. 4 to 7 is moist enough. Once it's getting to 8 to 10, it's too wet. And you will see if you put in any of those piles now, it will be in the red. When we are mixing it and adding water to it, we'll be testing it until it comes to moist. And I will tell you to take sample at that time and try it, and you see the difference. Okay? It's easy for you to use that.
So now this test should be done midday or in the morning, even when it's...
What I always recommend is that if the person that is going to measure it decides on a time that is convenient for him or her, and keep that same time every day.
So don't take your draft and,
Yeah, so if it's going to be in the morning every time, measure it in the morning every time.